datetime offsets and anchors. What's that all about? Pandas is incredibly flexible when dealing with dates. You can perform just simple arithmetic operations. I can subtract 2 dates from each other. And I don't end up with another date because that wouldn't make any sense. But what I do end up with is a time delta. And so you can see here in my output, when I subtract them and assign it to this new column called diff, we actually end up with 4 days, 5 days, 6 days, however many days apart those 2 dates were in absolute time. And we can actually go ahead and we can construct time delta objects by hand. We don't need to perform any arithmetic. I can simply parse time delta 1 day and 2 hours, and I get an object that spans 1 day and 2 hours. Additionally, I can supply any type of strings and I can supply any type of keyword arguments to specify how much time this time delta covers, how much change in time. Again, I cannot supply month, I cannot supply week to a time delta. Since this is measured in absolute time and not calendar time, we can only supply days, hours, seconds, and below. Because a month is ambiguous in the amount of time that it covers, right? February doesn't always have as many days as the other months, and so we can't do things like that because it does result in an ambiguous change in absolute time. Additionally, what we can do here is we can actually use these time deltas to add to our existing dates. So if I start off with 2011, November 5th of 2011, and I add a time delta of 1 day to it, I end up with November 6th, 2011 at 1 hour. That's strange. It's not strange if you're familiar with 2011 though. This was the day, again, this was the day of daylight savings. So we fell back. So although our timestamp is not an actual day right ahead, the change in absolute time is still the same. We have accounted for daylight savings by adjusting from PST to PDT, vice versa. And in accounting for that, our date time looks like we didn't actually adjust by 24 hours or by a full day, where in fact we did. On the flip side, instead of using a time delta, we can use a date offset. Now I'm telling you that there's 2 different ways that you can adjust dates. You can either use a time delta, which it changes your dates in absolute time, or you can use a date offset, which will change your dates according to calendar days. And so this will simply just be 1 calendar day after the inputted date. And so in this case, I inputted November 5th at 2 a.m. and I got out November 6th at 2 a.m. So depending on the type of operation that you want to perform, and also being aware of things like daylight savings, you can use this date offset to actually circumvent some of the shortcomings of date times. But that all depends on the analysis that you're running. One of these is not better than the other. They simply have different purposes. Additionally, you can also use anchored offset strings. What that means is when I create a date range or when I create some rule for resampling, or anytime you really see a string passed into these datetime functions, as part of this frequency, you see that I'm saying give me 3 periods that span a day, right, starting at February 1st. And so when I do that, I get 3 dates. I get the 1st, the 2nd, and the 3rd, since my frequency is day. If instead I pass in a W, I get each week according to that day, or according to my start date. So now I get dates that are 1 week apart, starting at Sunday. And if I don't want my weeks to start at Sunday, if I want to say, give me the first Wednesday of this month and then the 3 Wednesdays after that, I can simply specify weekly anchored at Wednesday. Additionally, if I want a span of months, I can pass M, and so I get the last day of each month starting at this start date. But if I want, say, the first date of each month, I can use MS for month start. And so Pandas gives you a lot of different ways that you can create your strings, that you can create these spans of date times, or that you can anchor them to certain days in certain parts of the month. And so you have these offset objects where instead of performing, add one calendar day to my existing date, I can say add one business day. This is kind of an aware manipulation, because if my day starts on Saturday, the next business day isn't until Monday, right? And if my day starts on Tuesday, the next business day, is Wednesday, and Sunday, right, 2 days after. And so when I use this date time offset of a business day, and I supply n equals 2, we actually get 2 business days after the inputted date. And so you can see here that we're actually rolling this May 5th or May 2nd to Monday, right, which would be the 4th, and then we get that business day and then the following business day after it. Additionally, you can supply things like month start, and so I'm getting, instead of getting the 2 business days after my inputted date, I get the month, that 2 months after this start date. And so you can use these date time offsets, right, as ways to perform rounding even, or perform some type of grouping, or making sure that all of your dates are valid as a way to roll your data into spans that you can more easily work with. If you're doing a lot of trading, you may want to make sure that you're ignoring holidays or things of that nature. Speaking of holidays, you can actually create what's called a calendar in pandas. And all a calendar is simply, it's used primarily for holidays. It's a holiday calendar. You can supply rules to locate holidays. Now, if you're familiar with US holidays, some of them occur right on specific days of the year, but we typically don't take off work on the day that the holiday happens if it happens on a weekend. A great example of this is July 4th. July 4th, although always celebrated on July 4th, right? If it happens on a weekend, jobs and businesses will typically not open on the nearest work day. And so we have this dynamic way of creating our own holidays that we can either choose to include or exclude specific dates of specific times in our analyses. And so if I create this calendar and I say, give me all the holidays that happened from 2015 up to but not including 2016, we can see I get each of these holidays. Here we have the nearest date for July 4th, and here we have Thanksgiving as well as Christmas. Now the Thanksgiving one is quite interesting because Thanksgiving is one of those holidays that doesn't happen on a fixed day every year. Instead, it's the 4th Thursday, right, of November. And so if I just make a holiday, and I call it Thanksgiving, and say this holiday happens on the 11th month of the year every year, and we're going to start at day 1. Now I know that Thanksgiving doesn't happen on November 1st. Instead, we're going to offset our day by 4 weeks, right, starting anchored at Thursday. The third weekday when you're supplying a week is Thursday. We start at Monday being 0. And so we can actually use this idea of a calendar to get spans of date times that actually represent and confer to real holidays in order to perform analyses that either include or exclude them, or even highlight them if you're expecting great returns or something of that nature.